Testing. Testing. Oh. There we go. My camera figures out how to refocus. Anyway, last time we were here, well, it's been a while. Longer than perhaps it should have been. I've been kind of uninspired to work on this since the next thing to do is basically refactor. And, well, I mean, it kind of works, but really I should refactor it. And so, yeah. Alright, so what we have here last time is we did a whole bunch of tests in preparation for refactoring. These tests tested various aspects of the parser, including its output to make sure that the output was correct. I really ought to... There's one thing that needs refactoring, that needs rethinking, is the way the visitor system works, because I'd like the visitor system to be a little more flexible than it is, because I would like to be able to use it for the formatting output. And the visitor system, in order to really be used for the formatting output, needs to be able to keep some state. Yeah, I'm not sure what to do about that. But that's neither here nor there for now. But I did add tests for all the string outputs for everything and all of that, and a variety of different expressions with different possible cases being handled and all kinds of stuff. And then the one thing that we did discover is that this, in fact, is right associative, and I didn't intend it to be. It was supposed to be left associative, and that all is all down to this. The way this is done. Problem is making the parser work properly when it's left associative is a little bit tricky, but we don't necessarily have to worry about that right now. Right now, the goal is to refactor. Actually, let's ask Claude here. Let's see. So we'll ask Claude. And I can tell you what it's probably going to do is it's probably going to say, oh, it needs to change to a term is a term plus or minus a factor. And then, or just a factor. And, yeah, it's a factor. No. That's not right at all. No. That is not right. Exactly. So expression is term or expression followed by a term. And term is factor or term followed by a factor. Basically, what you have to do is you can see over here that term is factor or factor followed by a term. You have to swap the term part, the part that expands recursively, to be on the left-hand side instead of the right in order to make it left dissociative rather than right when the parse tree is created. It actually makes the production, the implementation in a recursive descent parser a little more complicated. But that's exactly what I expected needed to change. And I should have actually caught this myself. I shouldn't have needed this test to tell me. In fact, I should have tested for this by hand when I was first coding this up instead of. Oh, and there's another version of Sea Lion, and I just downloaded a brand new version of Sea Lion not too long ago. I kind of wonder what they fixed. I doubt that they fixed anything that's actually relevant to me, even though I do like to have the latest version if I can. So, anyway, here is our I'm going to put this over here now. We have our test, and then we have the parser. So what we want to do now is we want to, now that we have our test to verify that things work, we gotta start trying to refactor our parser to remove all these special case endpoints where we go, oh, we failed to parse, and leave that decision someplace else. Now, for error handling, I'm not sure what to do about that. I'm going to punt on error handling and then maybe add it in later, which of course might necessitate another refactor. Maybe I'll organize it all wrong for error handling. But right now, I'm not going to think about that. What I'm just going to think about is how to structure these. So let's look at the very simplest ones, right? What is a factor? It's an identifier or a numeric literal or parenthesized expression. So let's look at factor here. So here we look at parse factor and we go, are we done? And if we're not done, then we look at the currents token. And if the current token is not an identifier, then what we do here is we it's an identifier pointer. Interesting. Gets turned into. If it is an identifier, then we go, okay, we found a factor, and then we return the identifier expression. A new identifier expression with our identifier as the. So that's great. Otherwise, is it an unsigned integer, right? Basically numeric literal. And I should actually change this from unsigned integer to numeric literal. I don't know whether I should change it or not, because the only kinds of numeric literals we have are unsigned integers. I didn't want to handle signed right away. Maybe we'll get into actually having a type system for this parsed language at some point. But right now, unsigned integer. So here, indeed, if we discovered that we're looking at an unsigned integer, then we just say, yep, we got a numeric literal expression. Turn that, and the next, the one after start, right? Next start, which is basically the equivalent of plus start, kind of. Except it doesn't. This is the equivalent of start plus 1, except it doesn't do the plus 1. Because plus 1 only works for random access, because if you allow plus 1, then why doesn't any integer work besides 1? And so it's basically uses, doesn't matter. It's the next one. So, we advance the token. say we've consumed a token. And then otherwise, if we see a parenthesized thing, if we see a parentheses, then we check, is it an open parentheses? Oh, if it's an open parentheses, oh, we've consumed a token. Now we try to parse the expression. And, for the rest of the tokens that we've got. And so, this does that parse expression work. Make sure that it works. And we get our expression back. Did we actually get... if once we parse the expression, we are done, then, well, something went wrong, because there's supposed to be a closed parent. And so then something's wrong. Otherwise, we check, did we get a parent? And if we got a parent, is it a closed parent? Then we successfully found the thing that we're looking for, and we go to the one after the remainder, the pointer at the remainder of our tokens, because we've discovered that's pointing at a parent, and we want to move past the parent. So we say, yep, we found an expression, and here's the next token after the closed parent. So that's that. And then here we say expected closing parent parse aborted. So then we go, okay, we didn't get a parent, we didn't get a closed parent, and so we're just going to abort here. All right. And then down here we also say if we didn't see a parent. So these are kind of redundant. And this return here is great. Like, this return here means that as long as this return is hit, then we know that all the bad things happen if this return isn't hit. So we can actually just, one of the things we can do to refactor here is we can just say so if remainder is not equal to finish, then we do all this stuff. And then here, tab this. This is at 84, so we should probably yeah, here's what we should do here. Like that. That's how this should look. And that's just at 80, so that's barely good enough. And then we can go like this. That is how this should look. And then we check, was it a closed parent? Da-da-da. Then this also needs to be indented by 1. And then this. So that's great. And then that's great. So if none of these cases fired, then we should just say expected closed parent parse aborted. Oh, here's where we should say, if we got in here, we saw the open parent. And then down here we say otherwise expected factor parse aborted. So this should be equivalent code. Let's try running our all tests and see if it actually runs. Yes. So this is, although the code doesn't test any kind of error conditions. But aside from that, this is equivalent code. So it handles all the good paths that it's supposed to handle. It may not handle the error paths in the way that we hope because we didn't do any testing to check about the error paths. Because to some extent, they're all really broken anyway, and we don't care. That's actually one thing that will happen as a result of this refactor is a bunch of new tests testing error conditions, which will also mean that I will have to do something more sophisticated than this. And it might also mean that I have to start returning something other than just parse, or make parse result t a more complicated type. Maybe make it a, yeah. We'll see about what to do there. But yes. All right. Actually, I'm kind of curious about something here. It's impossible to tell if anybody is watching on Google, on YouTube. Oh well. So there's one refactor done. This refactor wasn't that important. The main reason I wanted to go through this function is to verify that I'm in fact doing the right thing here. That I'm looking for all the stuff that does match. And then if there's anything that doesn't match, I go, oh, it didn't match. And then, tossing it out. Because that's the right way to write this function. So now let's see here about parse term. Is there anything else that's really, no, because all the other ones are really built on top of things. Parse term is the first one. So we're not going to try and fix right now the right associative problem. We're going to leave it as right associative. But we are going to try and fix the special casing type stuff. So we're going to look for just the things that match. So we check. Can we parse this as a next thing as a factor? If we can, then that's great. We just found a term. And if we're at the end now, we go, that's great. We just found a factor. And if we got to the end, that's great. We just found a factor, and that's great. Otherwise, if we didn't find a factor, then that's a problem, because no matter what, if we're trying to parse a term, we expect a factor. Like, no matter what we do, the first thing we expect is a factor. So if we didn't get a factor, then this is not a factor. And we should just go, yep, it's this is not a term, and so we should say, okay, parse aborted. This is not a term. Otherwise, because this is inherently an otherwise, because this is a short circuit return. And it's saying that the else is redundant because of the short circuit return, and it's right. So I should be consistent here and fix that. That's a refactoring right there. And then second return, first return, second return. Then after the second return, and we check, is there anything else there? Right? We know remainder is not equal to finish, so we know we have more things. So we look at the next thing. We assume it's an operation. No. We're doing the wrong thing here. So what we should do here is we should say if auto const op like that. So if we're looking at an operator, then we check, is it operator multiply or divide? If it is, then we go, okay, well, let's eat that term. Then we try and parse the rest of it as a term. And it's deciding our remainder for the remainder, and our term for the, so basically right term and right remainder. And then if our term, if we actually got a term, then we return it. Otherwise, we say, well, no, if we got a term, then we return it. Otherwise, we complain that we were expecting a term and the parse aborted. We shouldn't be doing that. What we should do here is just have a bunch of things that all, when it's saying this else is redundant, oh, that's because there's a return there. And so what we should just do here is zap this. If our term, then we return the term that we just, we basically make our binary operation, and we have the left and the right be the factor in the term, and then the our remainder, which is basically whatever happened after attempting to parse the next term. Yeah, that's the right thing to do here. So here we try to do this, and oh, this is yeah, this is going to be interesting. And then here, oh no, that's not what I wanted. Here I wanted op remainder. basically what we want to do is avoid advancing remainder. Treat it as const, actually. So then we go op remainder, and then if we get down here, that means we did not successfully parse this part right here, right? So we didn't parse we're trying to parse a term, and we parsed the factor, but we failed when we tried to parse this part. And we saw the plus, star or slash, right? We may have seen the star or slash, but then the rest of it wasn't a term. So it doesn't fit here, right? It's not this kind of an expression. And so instead of like going, oh, we saw a star or slash, and then we didn't find a term, and therefore that's a problem, we should just go right here, is once we try and parse the operator and fail, like once we get through this, that means that we fail to actually do this part of our production, right? And so, but we succeeded at this part of our production. So in fact, we did find a term. And so we can just go return parse result, like this, right? Just like we had before. One thing we could do is we could just wrap this entire thing in remainder not equals to finish, and avoid duplicating code. I'm tempted to do that. The short circuit return makes things seem simple, but I don't like duplicating code, so we're going to do it that way. And then we're going to say if remainder not equal to finish, and we're going to keep this part here. If not factor, then that was a problem. If we didn't find a factor, then we clearly failed. So here we're going to have to indent all of this by one more. There's a whole big bunch of lines here that are just too long. The cutoff is so here, and then we're going to do this, and we're going to do this, like that. Wonder if I can ask Claude to infer a bunch of playing tidy rules from this code base, and then implement them. So this is not past column 80. We're looking down here, which you might not be able to see if you're watching this, but that's what we're doing. Looking down here and looking to see if it goes past column 80, and if it doesn't, then we're fine. For example, this doesn't. I like keeping everything to column 80 columns if I can. So here, the C-Lion is putting in a whole big bunch of little like comment type things, but if you actually look down here, this is only column 72. So when you actually just print the code out without C-Lion inserting its like little stuff to try and help you, it comes out the way it's supposed to, or it comes out to being not too wide. This one though goes all the way out to column 108, so it is definitely too wide. So here we have binary operation, and then we're just going to do like that. Oh, except no, like this. Yeah, like that. That's what I want. These things make things confusing for lining stuff up sometimes. But now, like this one, for example, is at column 73, so it's just fine. What's funny is this one is actually only to column 72, so it's technically shorter than this one is. Okay. And then here, so this is the part that checks to find out So I'm going to put this comment here. So basically, if there might be a remainder, check. Is the stuff after what we're currently looking at actually this? And we don't care if it isn't, because we already got our factor. But we should check just in case. Now, yeah, the way we do this when we change the associativity is going to be a little weird. But for now, this works. And then we can say here, we got our factor, right? Okay, so this is refactored. It's now simpler. There's no special cases for short-circuiting and going, we got a parse error. Like, I don't try and pretend I know that there's a parse error when there isn't one, or when there is one. I don't try and pretend I know there's a parser error when I think, because of the various rules of the grammar from a global perspective, that this has to be a parse error. I'm going to not pretend I know the rules of the grammar from a global perspective. And so I'm just going to assume that this isn't, this may or may not be, as long as we got a factor when we're, because we tried to parse a term, as long as we got at least a factor, we successfully parsed a term. And that's great. So let's find out if this runs. All right. So all of our attempts to parse valid statements work great. We do indeed parse a whole lot of valid statements here. Okay, so what's next? I should have had welcomed JustEvix. I can't see all the people who might join on the 3 different platforms I'm streaming to, but yes. What does this do? Okay, this is this little symbol here, and I don't know what it does. Recursive. Oh, this is a recursive call to parse term. Yes. Okay. So, yep, this refactoring works, and this provides a kind of overall template to refactoring some of the other stuff. Now, parse expression. So expression is basically a term followed by possibly a plus or minus and an expression. So it's essentially the same thing as term, but yes. So if we're at the end, then, well, no, we did not get an expression if we're at the end. We got nothing. All right. So here, if we're if we're at the end here, or not if we're at the end. If we're not at the end, then we should see if we're at a term, because we're expecting here for expression, we're expecting a term at least. So let's see, did we get a term? And that's, here we should have if not term. So if we didn't get a term, then we go, okay, parse aborted. And this is the wrong message, because I should return an error here that I did not get a term, but I shouldn't say parse aborted, right? So, because I don't know why I didn't get a term. Might be that there's a thing where there might be a term or another one of several different kinds of expression that I might there might be as an alternative, and I don't know which one it is, and it didn't happen to be a term, and so it might be the next one, and I don't know that here where I'm looking and finding out that I didn't find a term. So that's not the right message here. I should or it might be where someplace where I'm expecting maybe an expression, or I might be expecting something else, right? I don't know. And so I don't know that because I didn't find a term that something's the matter. It might be just that, maybe I add something where the sequence is inside of braces, for example, and I didn't find a term because I found a closing brace. That's not an error. And so I shouldn't complain. I expected term parse aborted, because it wasn't aborted. The upper thing that called it was going to go, I didn't see an expression. Let's check. Is it instead a closed brace? And then it will see that, it is a closed brace. Okay, that's fine. So, yes. Anyway. Now, let's see here. So if we didn't see a term, we spit out this misleading message and then go, yep, we didn't find a term. We didn't find an expression because we did not find a term. So now we say if remainder not equal to finish, and then here this all goes down to here, right? And yeah, we can anyway, I'll figure out this part down here when we get to it. It's basically going to look like what happens. Yeah, here we're just going to I'm just going to say, yep, we found our term. Okay. Now, all of this stuff, I don't want to stop here. It's clicking in the wrong spots. Anyway, so we go down like this. Just a bit. So, not see here. Think. I wonder if Twitch has some kind of feature where you can have sort of a little title about what you're doing right now. That would be kind of nice. Because then I can say, you know, I'm refactoring or whatever it is that I happen to be doing. So, anyway. Okay, so that's what we do here. Now, if remainder is not equal to finish, let's look here. What do we try to do? So here we should instead say here for this, equals, and then here, what do we do down here? We did get if, standard get if. Yes, like that. Yep. And then here, oh, well, that's very interesting. And this is the we don't actually care about the equal sign here because we're trying to parse an expression, and expressions don't have equal signs. It's statements that have equal signs. So then here, we did see an operator. Now here we check to find out. Is our op and I think that this is not quite the yes, there we go. Like that. Now this is way over the heck at column 91, so we got to split this up. Here's what we're going to do here. If or like that. So if we're looking at a plus or a minus, then we go, okay, then we go, so there we go here, and then here we parse op remainder, and then if we got an R term, then this is great. This is what we want to do right here. And I can just change this to opval instead, and a bunch of other code works. There. Alright, and this again is way out at column 75, so we're fine. R term and R remainder, that's great. Op remainder, we start op remainder, so basically the one after the operator. And then if we find the R term, and that's great, we go, okay, we found a compound, and then we make the compound, and we're all done. So that this is all correct. And this is at line 98, so we're going to have to do this like that. All right. And then got that part and this part, which matches up with that. Basically, we have a cascading bunch of stuff that did the right thing here, and which also means this needs to be tabbed in by one more, like that. Anyway, so not see here. Da 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 da. Check. Check this again. How far ahead are we? This is still at column 78, so we're good here. So first, we're not at the end. Next, we are looking at an operator. Next. In fact, the operator is a plus or a minus, which is what we're hoping for. Then, and the next thing is I should actually call this R expr instead of R term. So we're going to rename this. And the magic of CLion is going to cause the rename to stick, like to rename all the places where it's actually used. And it knows that when I said R term here, I meant that, but when I said it someplace else, I didn't mean that, and so on and so forth. Like, it's smart about its rename. It's kind of nice. One of the nicer features of CLion. Op remainder is the after the operator, the right remainder, so R expr. If we did have a right expression, then we have a binary operation, and the operator is the operator that we looked at, and the left-hand side is the first term that we parsed, and the right-hand side is the remainder expression. And then, but if we got here, then we at least got the term, and so we should, yes. Now let's double check this one to make sure that we follow the same logic here. Also, too, maybe we need to rename this. Yeah, we should rename this not to our term. It should be, this is our term factor. Okay, Yep, we called it term here, so we have factor and term. That's good. Okay. So we did the right thing here. We did not do the right thing here. We named it term instead of expr when it's actually an expression that we're trying to parse. Okay. So that's great. This, again, should be the right thing for expression. No special cases. Oh. What is the wrong here? So yes. What is wrong here? What does it not like? Why is a function definition not allowed here? Oh, it's because no, that's not the reason why. This is perfectly fine. Parse term. Oh, I got something wrong here, and so it's showing up here. I'm missing. Yes. I'm missing the close brace for that. Now I bet it'll work. Aha! Expected semicolon. Aborting. Alright. So that means that parse statement was relying on something in parse expression to operate a certain way, that it's no longer so this one here, all statements are parsed into a statement list, and it failed to do so. So something about the statement list is now not working. But on the other hand, so suppose I mark this test. Is there a way to mark this test as don't do this test? I do get a lot of... Oh, there's a bunch of failed assertions, but I only had one failed test. So all the rest of the tests succeeded. That tells me that, in fact, the main issue is in parse statement list or parse statement. Parse statement list, something is going wrong. So let me check here. Parse statement was relying on some kind of thing going on here. Oh, is there one other feature of this? This test also contains assignments. So, and I was in fact looking for equal signs in here, and so something wasn't working out there. So parse expression. Let's assume that it's correct now. Now parse statement. Let's look at parse statement. A statement is either an expression or identifier followed by an expression. So let's find out. Is it an expression? And we can't just look at whether it's an identifier or not, because we have to find out. Expressions can start with an identifier, right? So we need to find out whether it's an expression first. Yeah. So if we found an expression, there's a problem here though, because just because it's an expression doesn't mean that it's a oh, this is tricky. This is really tricky. Because this isn't valid unless if the next one is equal, then we need to, yeah, because a single identifier is a valid expression. So after we get a single identifier, or after we get a valid expression, we have to check to see whether it's an equal sign. And then we have to check to find out whether the expression that we just got is in fact an identifier expression. And yeah. So basically, another way of doing it is if we get an expression and then we get an equals, then it's not a valid statement. Or we need to try a different tack. Like it's yes. We have two different kinds of statements that it might be, and we don't know which one it is. This is a little tricky. Also, too, we're coming up on, I got about 10 minutes left, so I probably actually have enough time to figure this problem out. Anyway, we keep having people show up and then watch for a little bit and then disappear, sadly. But, so this is the problem. So here's what we'll do. We'll check. We'll do it in this order here. So statement. This is actually parse statement list. This is not just parse statement, and so it's kind of misnamed. Maybe I can rename it. So we're going to rename this. So there, it's got renamed everywhere, and in Lexer test where I call it, got renamed there too. And in the tests, it got renamed there too, so that's good. Okay. So here's what we're going to do. We're going to do this. This is going to be ugly, but we're going to do it. If we're looking at an identifier, if we're then that's not so if we're looking at an identifier, and the identifier token is that, we don't want to plus start. If after ID is not equal to finish, so we saw an identifier, and we look what's after the, we go after to the next thing. If there is a next thing, then if it's an equal sign, and this is after ID, then we go. So if what we found now is an equal sign, we're going to close all these things. Then we do this. Go after the equal sign, then we try and parse an expression. If there's no expression, then this is a case where we can do this. Again, we're special casing here, but parse statement list is also the top level parse. And this, if there's a place where we can decide that we have an error, this is it. So if we ever make statement lists something that's not the top level production, then we'll need to go through here and fix this to no longer work this way. But right now, because it is the top level production, this is a place where we can say definitively we indeed have an error here. So otherwise, we say statement equals make unique assignment state. So there we go. That's what we do here. Now, And we also say no, we'll do after equals remainder because that's what we did here. So we'll do after. So one of the things that can happen here is we can find an identifier, and then we can see, oh, the next thing is not an equal. And if that's the case, then we just drop out of here without ever having assigned to assignment. So then we try and parse it as a there we go. Yep, that should be correct. Now I bet our test succeeds. Yep, indeed our test succeeds. So part of the problem was that some of our logic involving the equal sign and the semicolon and all of that stuff was down in here, and it shouldn't have been. This shouldn't have had any of that logic, which is one of the reasons why I wanted to do the refactoring, because that logic doesn't belong down here, it belongs here. And so that's what I just did, is I moved that logic here. There, putting in comments. Okay, there we go. Okay, now we're going to go through this and look for lines that are longer than 80 columns because, you know, I and me. Okay, 79, so no. 97. Ah, so yes. 67, so where is 80? 80 is right around here. So and that actually goes over here. That's how this works. That will cause the basically string. When you have adjacent strings like that, C++ just squishes them together automatically. That only goes out to column 61. This goes out to column 97 again. So here, this is column 71. So we're going to do this, and then like this, like that. Okay. There, which column is that? That's column 79, so that's good. This is column 85, so that's not so great. That's what we should have here. All right. This is all good now. All right. So I wonder what the AI thinks of this commit. I often wonder what the what happens with the AI when I do stuff. No, that is a bad choice. Yep. So AI is not necessarily good at writing commit messages. In this particular case, it completely missed the whole point of it. Now, I wonder if there's a way for me to say yeah, that's the right answer. But I'm going to do it here. All right. Oh, yes. So we saw how having a bunch of tests made it so that our refactoring was works that our refactoring resulted in code that was just as good as the original code, or worked just as well as the original code, which gave us a lot more freedom to refactor. Like, we weren't worrying that we were breaking all kinds of stuff. And also, too, when we did break something, it was really obvious, and also kind of obvious where we needed to go to fix what it was that we broke. Like, it just helped all around to have a whole big bunch of tests before we started refactoring. Anyway, that's it for today. I hope to be back probably Thursday. So talk to y'all then. Till then, have a fantastic rest of your day, wherever you happen to be.